Hey people, we have got another piece of old test equipment on the bench. Once again, I found it in the deep, dark, dank depths of Akihabara. This is a Matsushita / National / Panasonic electronic counter. This is an old piece of equipment, so it's branded Matsushita. Matsushita, however you want to say it. It's a VP-4541A, and it's got Nixie tubes. Hence the reason I bought it, even though it's not working properly, because we're going to fix it. There's 6 tubes in there, and it's a counter. It's got frequency on one side, and it's got like duration on the other, so you can measure, I guess, pulse width modulation, or the time between pulses and that sort of stuff, or the number of pulses. So yeah, it's kind of a handy sort of size bench mounted unit. Got a little stand on the bottom there that you can flick up so that it can, rather than sitting flat, it can kind of look up towards you if you need be. On the back here, there's the brand there. I don't know if you can see that. Matsushita. 100 volts and 200 volts input. Well, 100 volts / 115 and 200 / 230 volts. So seems like it's a universal voltage input. And we got a scope and external reset and the ground here on the back. So I guess you can hook your scope up to the back terminal here and see what's coming into this unit. So there's a little bit of a dent on the back there. You can see here. It's not quite straight. I don't know if I'm going to be able to straighten that, but it's not really too bad. It's not. I don't think that's going to cause much of a problem. And yeah, it's got the usual old. I can see in the side here before we open it up. It's got the usual 7400 series logic in there. So it's not completely archaic. It's just halfway archaic. And as is usual for Japan, we've got the earth plug with the earth snapped off, because a lot of outlets aren't earthed. They don't use earths here for some reason. And as I always mention in videos, kind of annoys me, but yeah, we'll be replacing that with an earthed plug, of course. So usually the tradition is to don't turn it on, take it apart, but we'll just quickly plug it in, bucking the trend, and turn off some lights. There we go. That's what we get. And if I hook up my function generator, it kind of gives randomish sort of numbers. It's not working as it should be. There's a little G down here. I'm not sure what that is, but G pops up every now and again. I'm not sure what the go is, but it's not working. So I'm going to take this thing apart, and we will see if there's anything obvious inside, and maybe I'll try and track down a manual or a schematic. I haven't been able to find something with a cursory glance at Google, but yeah, maybe we'll find something. Some manufacturers like Kikasui are very good about keeping manuals available, even with very, very old equipment. Some other manufacturers just don't. You're pretty much out of luck. So it's just a bit of a shot in the dark, see what you can find. But let's open this thing up, see what's inside, and see what we can figure out to start with. Alright, to pull this thing apart, I think we're going to have to undo a few of these screws on the bottom. Probably those 2 at the back and these 2 at the front, because I think this blue section just slides back off of the rest of the chassis. And that was kind of a common way of doing it back in the day. I've seen a few oscilloscopes like that where the whole outer case just slides off. So get these ones out, and hopefully that means this thing comes apart easily. Oh yep, there we go, it's coming out. I'll just get that out of the way. Alright. There's our board. So we've got our Nixie tubes, 6 of them there. Looks like our driver's lined up there. Whole heap of logic doing some logical stuff. that black box there has got all the little designators like kilohertz, milliseconds, microseconds, and then G. And there's a little neon on the side here as well, with maybe a drive transistor there. So we can give all that a clean up, because that's a bit dirty, a bit fluxy. Underneath, well, there's something a bit loose in there. I wonder what that is. Oh, the transformers come loose. Oh, the screws on the transformer are loose. Okay, we'll have to tighten those up. That's just kind of like sort of waving around there in the breeze. So we've got the power supply section anyway there. That whole board with the big filter capacitors, big axial caps. What brand are they? Probably Panasonic or something. I can't quite see. 3 diamonds. I can see 3 diamonds. And then we have a board here on an edge connector into the front board. That front board has got all the switches and dials. And that would be probably the counting stuff, more of the brains of it. Well, that's the interface anyway. There's a whole heap of diodes and resistors, so that might be input protection. And then we've got what looks like this is probably doing all the counting and comparison stuff, because it's got, like, you can do comparisons between the 2 channels, A and B, so you can sample between A and B. So that's probably doing all that, because there's a whole bit of transistors on there, little metal can transistors. So there's a problem where it doesn't work. So I'm going to have to start poking away, start figuring things out. It's going to be a bit boring to show you the whole process. So what I'll do is I'll have a bit of a poke, and when I find something interesting, I'll let you know, and I'll explain exactly how I found out what I found. Alright, I'll get into it, and I'll be back in a sec with a bit more news. So I've got the top board off. Just had to unsolder a couple wires. This one here, and one over here, and then there was a plug, the orange one I done solder, and then this plug here, and then just lift it out. There's a few sockets here as well. They just unplugged, and here's our board. I thought I'd have a look inside this thing, because this is where the like the range indicator is. Got a little plastic cover, and then underneath it just a bit of diffusing plastic, so that's like just a little light box there. But inside it actually has neons. You can see that there. No LEDs or anything in this one. I'm going to take that off. Have a bit of a closer look. So each segment has 2 neon globes. Look at that. That's pretty cool. So we've got 4 segments, 4 globes, or 4 tubes, globes, bulbs, whatever they're called. 4 sections, sorry, 8 tubes or globes. So yeah, they just light up and then shine through. Too old for LEDs, and I guess neons are much longer lasting than incandescents, and they don't heat up as much either, so they don't yellow your plastics or cause things to go brittle. And you got high voltage anyway for the Nixies, so you may as well use the same voltage for your neons. There's a little bit of corrosion on this board too. You can see around these transistors, so I might try and clean that up a bit. Hopefully it's not cause any problems. It doesn't look like the traces are damaged, it's just a bit of humidity or maybe a bit of moisture somehow got in there. This may have been wet. There's a little bit of dirt on the board as well, so it may have been in the shed. A bit of rain got in somehow. But we'll give it a clean, some isopropyl alcohol, see how it comes up. It seems as though this board works, so I'll clean it up and then just leave it for now, and then we'll start digging deeper into what's going on inside here to see where the problem is. Alright, so I've got the that board back in, all nice and clean. Beautiful Nixies there. And I've also gone and cleaned that one in there. Pulled it out, stuck it in the isopropyl alcohol, gave it a scrub, stuck it back in, deoxited. Use deoxit on the connectors anyway. Whatever you call that, deoxiting. tighten up that transformer as well, so that's nice and firm in there. And I've got here the power supply. This is a power supply board. Everything in this thing is quite modular, which is nice. So we've got the input here. That's what comes from the transformer. We've got a couple of bridge rectifiers here, and then some nice big stud diodes for some high current power supply. 4 of them there. Of course, that's a bridge rectifier again. Full bridge rectifier. And we've got a couple of smoothing caps. These are on the output side because they're only low voltage, 16 volt. 2 of those are for these stud diodes, and one of them is for this bridge rectifier here. These ones here, high voltage, 160 volt. There's 2 of them in series so that they half the capacitance, but they double the voltage, and they're 47 microfarads, so they're acting as like a 24, 23-ish microfarad capacitor, one wired in after the other. Then we got this one here as well, which is from this bridge rectifier coming to here. That's 1000 microfarad, 25 volt. Axial caps there, get a bit hard to get, but I can still get them. Probably not this brand, but I'll use, I think I use Nixie or something. Yeah, Nixie, I think they are. Can't remember what series, but yeah, I can still get them. Then over here, there's our output. But before the output, we've got a few packages here, some little shiny, you can see them, the little shiny cans. Old style voltage regulators. They are LM305H. 3 of them. And there are voltage regulators which are controlled. We can trim the voltage with these 3 pots just here. And because we need more current than what these things can deliver, we've got 3 transistors. So basically what these things are doing, these are trimming the voltage or adjusting the voltage to be what we set it to. They're regulating that. And then they're actually controlling these 3 transistors, 1 voltage reg for 1 transistor, and the transistor is what's passing the high current. That way we can get a lot more current than what these things are rated at. There's this other one here, which is a, what's that, A546A. That's another transistor of some description. Just, yeah, it's a 3-legged component. That may be something to do with the high voltage. I'm not sure. I haven't looked that deep into it, but yeah, we've got basically 4 outputs. Orange, purple, blue and red, and with the black, I guess, is the ground. Yeah, the black is the ground return. So it looks like there's 3 regulators plus this transistor are probably doing the 4 voltage that's needed. Maybe there's 12 volts. Being TTL, we've got 5 volts. I don't know, 24 volts, and then like 160 volts or 90 volts or whatever voltage the Nixies are running at. Probably that transistor, I guess. But yeah, so I'm going to give that a clean. Replace the caps as a matter of course, just because. Caps are cheap, so may as well do it. And I noticed there's a bit of a scorch on the board here. You can see there. That's this 10 ohm, the big green resistor just the end of my finger there. It's a 2 watt, 5%, 10 ohm. I might replace that with a slightly larger one, maybe a 5 watt or something, bring it up a bit higher. Or I might not, I don't know. It's obviously heating the board a bit, but if I bring it up away a bit further and then use a high wattage resistor, that's going to be physically larger, so it can dissipate the heat a lot better and won't cause a problem. But that's kind of a, if I can be bothered. This thing's was built like, what, nearly 40 years ago, and it's hasn't gone too bad, so we'll see what happens anyway. I've also got this board, or these 3 boards. This is our front panel board. I'll be deoxing the switches and the pots as I can. We've got a rotary switch there and a few pots here and there. All these switches, so I'll give those a squirt. You can see there's a lot of flux there. See all along here? Get the isopropyl alcohol onto that. Get rid of all that flux in there, make it nice and clean, and if I can be bothered, might replace all those caps too. There's only like 12 or 13 on there, so it wouldn't be too difficult to replace them. Give the board a good clean. This side doesn't have any electrolytic capacitors, no aluminium caps there. Just 2 trim pots for calibration. I've got to find out what they are. If I can find a manual for this thing, I might talk to, I don't know who I'd talk to, Panasonic, Matsushita, someone. I might be able to send a few emails in Japanese and see if I can find some information. But if you notice on here, Look at the base of all these ceramic caps. You see that there? Every single one. Can you see it? There's all these little glass beads on the bottom of these caps. Now, I'm pretty sure they're not being used as any dielectric or any insulation or anything like that. They're just loose glass beads, but I think they're just being used as spacers, just to space these capacitors up off the board so they don't like fall down, or they just to keep them neat or something, or a bit of support. If anyone knows if there's any specific reason for that, let me know, because I'm interested. I've never ever seen that done before, and that's something that would have to been done by hand. Like someone sat there and put those beads on one by one on every single one. So yeah, let me know if there's any specific reason. I think it's just to keep it neat, so they space up all an even amount. But yeah, every capacitor on this side has done it, but these ones on the back of the board, they don't have them. So what about these in here? Nothing on this board has it, but the power board does, I think. Yeah, look, that one there, and even the on this board, all the ceramic caps have got the beads on them. So I think it's just making it neat. It actually seems like quite a well produced bit of kit, this thing. Everything's nice and modular. Everything's plugs together and kind of links together logically, so things are easy to take out one by one. So this board was easy to take out. It just unplugs, comes straight out. So it's a nice bit of kit. But anyway, I'm going to head down to Akihabara. I'll get a few more bits and pieces and start replacing some stuff. Start giving a bit of a bath in the old isopropyl alcohol. Give it a bit of a clean, and once I've done that, we'll fire it up and see what happens with the performance of this thing. See if we can check if it's in calibration, and if it needs to be, how to calibrate it. So I'll be back in a sec. Just got back from Akihabara and got my jack, but it turns out to be the wrong type. I was in a bit of a hurry, didn't quite look closely at what I was buying, but I bought 75 ohm, not 50 ohm. This is just a cheap eBay piece of rubbish. I won't be using it, but you can see the difference in there. 75 ohm on the left, 50 ohm on the right. The insulation on the center conductor, or the center pin there, comes right up to the end on the 50 ohm, but not on the 75. It stays right down the bottom. 75 ohm is mostly used for things like video, that sort of stuff. 50 ohm is for your test equipment, like on your oscilloscopes and on your function generators and that sort of thing. So these will stay in the parts bin. I'll use them for a different project, but that's alright, because look at that. These were almost black before with tarnish, but now they're all nice and shiny. To do this, it's really easy. You're going to need three things. One is pull your jacks out of the front panel. You're going to need some episodes of Star Trek The Next Generation, none of this Deep Space Nine rubbish. And you're going to need some of these. These are the cleaning cloth for like jewelry and that, metal jewelry. This particular type is for silver, because I have another device which I'm fixing up in a different video with silver plated BNC. But much of a muchness has still worked really well on these, I don't know what they are, chrome or nickel plated jacks. And you can buy these from like dollar stores or hardware stores. It's inside, this has got three little cloths. They're like a fabric-y sort of papery cloth with some chemical impregnated into it, so that when you rub it on the metal, it takes off that tarnish real nice. So just got to just gently rub your BNC while you're watching your favourite characters, you know, Beverly Crusher and Deanna Troi and Jean-Luc Picard. Soon you'll be glistening in the sunlight, and you have some nice jacks just like this. Beautiful. They're the original jacks. I'll keep them in there. They look real nice. I'm actually really happy with that, how they've turned up compared to what they were. So once I've use the deoxit on the switches, replace a few capacitors, that will go back together and we can put that back in. I don't actually have the capacitors right now, but that's through the power of editing and YouTube. There was no time will be passed for you guys. It turns out that it's Obon this week, which kind of dates this video, but Obon is like a 3-day holiday, and most of the shops are shut, including the shops I buy my capacitors from, so I've had to order them from DigiKey. They'll come in 3 days, which interestingly is about the time I have to wait if I go back to Akihabara anyway. Just the difference is I get them delivered to my door for the same price as what I would pay for at Akihabara anyway, so it just saves me another trip. So next scene, capacitors. For you, 1 second. For me, 3 days. See you in a sec. Alright, FedEx delivered, and we have all our capacitors. So these ones here are for the power supply section. We have one that's wrapped in bubble wrap for whatever reason, because that one must be extra delicate. And two more here, they're the axial caps are going to go in here, and we've got the three radial caps, 50 volt, 2200 microfarads, which are going to go here. These ones in there are 16 volts, and we got basically the same size, and we got up to 50 volts. So yeah, actually the 50 volts are a little bit smaller, a little bit shorter. It always blows me away how small modern caps are compared to the old ones. And we've also got all the other caps to do the whole rest of the device. 1, 2, 3, 4, 5 different values. So I'm going to go ahead and put these in there, and then I guess I might look at replacing some of that heatsink compound and all that sort of stuff. And then we can do the rest of the machine, and then hopefully it still works. One thing I also noticed is they didn't use any elastic between these capacitors here. What they actually used was this belt. It's all sticky and gross because of age and whatever, but gave it a wipe with the isopropyl alcohol, and it's come up good. But yeah, just straps around like that and holds those things steady. I've never seen that before, like a belt, and the little plastic stud that just goes through the holes, and then yeah, it just clips on and holds those caps. So yeah, interesting way of doing it. Never seen that before, but yeah, I'll reuse that because the new caps are the same diameter as the old caps, they're just a little bit shorter, so that will wrap back around and hold it as intended. And yeah, we'll get this thing sorted out. So I'll go ahead and do that, and I'll be back once I've got some more progress. This is turning into a bit of a job. I'm going to be now respraying the front panel surround trim piece. It turned out that when I was cleaning the paint that was there with isopropyl alcohol, the isopropyl alcohol was actually taking the paint off. I don't know what sort of paint it was, but it wasn't that great. So I stripped it all off with isopropyl alcohol, so it's all nice and shiny. I gave it a good clean, and I've masked it off, as you can see. And that's going to get sprayed. So I've got some, what's this, primer surfacer, just some primer, one coat of that stuff, and then we're going to spray the whole thing in silver. Don't know how good your Japanese is, but silver. And then around the nixies behind the plastic screen, it was matte black, so I've got the matte black. So I'll go outside, spray this, and once it's dried, we'll come back in, and I think it's about time to reassemble the whole unit. I've repainted this so it's all nice and shiny silver with the black back in there as it was from factory. So the when you put the which way around, that way, when you put the plastic in there, it kind of once it's inside the case, you won't see anything there. It'll just light up and show the digits themselves. So I've got new screws as well. I've got some stainless steel screws which will look nice once it's all together for the front panel. And yeah, I'll put this back together, and hopefully it still works. I think it should work. I'm crossing my fingers, but yeah, we'll see how it goes once we've reassembled this thing. Alright, I'm just about to put this cover on, and I thought we'll just run through and just see exactly what we've done, just do a bit of an overview. So first of all, we put a new power cable on with the earth pin intact, so that's all good, how it should be, nice and safe. All those capacitors in the power supply have been done, of course. Axial where we need axial, and radial where we need radial. I replaced the resistor here. You can see the little blue one at the end of my finger just there. The other one was looking a bit like it being a bit hot. The circuit board's a little bit brown in there. Just a bit of prolonged, like, gentle heat, I guess. The circuit boards, you know, they'll go brown after many years of a little bit slightly elevated temperature. But I put a slightly larger resistor in there, and I've spaced it a bit further off the circuit board just to give it a bit more chance of getting rid of heat rather than putting it into the board there. Also down the back inside, you can't really see it, but there was a resistor there that had the lacquer or whatever it was coming off, and you could see the windings inside, so I've replaced that to make sure it's all good. A bit of thermal paste on the transistors as well, the 3 transistors in here, just so we can get the heat out, because the old thermal paste was a bit old and a bit dry, and yeah, a bit how you doing. So new thermal paste there, all good. All the circuit boards have been completely cleaned of flux. We've got new capacitors on these two boards here. Again, they've been cleaned. There was no faulty parts I could see on there. Turning it over to the top, this board completely cleaned, and just two new capacitors there. Cleaned all the Nixie tubes inside there. You can kind of see them glinting through the plastic. They're a bit dusty, so I've cleaned those up. Cleaned up the front panel, polished the front connectors there, and used deoxit on all the pots and the switches, and lubricated the switches so they're nice and smooth again, almost feeling brand new. I think that's pretty much it. Now, I can't calibrate it yet because I don't have the manual. There are a few adjustments, like these three here for the voltages. I can probably tweak that and play around with it, make sure the voltages are good. And there's a few pots on these boards, but I'm not sure what the value should be and how to test it. There'll be some test points somewhere, or you put a signal in and check that it's reading correctly, something like that. But I'll talk to National. National, who are now Panasonic. Hopefully I can find someone who's got a manual for this, or I could maybe find it online. Hopefully, I had a quick look and I couldn't see anything obvious, but I'll see if I can track one down so I can give this thing a proper calibration. So, oh yeah, and we painted the front bezel surround support structure thing. So I'm going to put this back together and we'll fire it up and see if it actually works. Okay, we're ready to test. We've got it all plugged in, all the way up to the frequency generator up here. So let's turn it on, see what we get. So if I turn that on, we should get zeros because we have the frequency generator is turned off. If we turn that on, we should get something on the screen. And we do. 6 kilohertz is what I've got it set to up here, around about that. It's an analog dial up here, so it's a little bit loosey-goosey. Squint your eye and hold your tongue in the right position. Crank it up to around 60 kilohertz. Looking pretty good. How high can we go? All the way up to just over 200 kilohertz, 217 kilohertz. That's as high as my dial goes, and it goes right down to under 20 kilohertz. 0.018, so that's 18 hertz, and everywhere in between. So we go around 500 hertz, 5000 hertz, 5 kilohertz, 50 kilohertz. Looking pretty good. So that's working. It's also, as it says on the front panel, it is a counter. So if I turn that around, we can start counting. And that seems to be working quite well too. So if I turn that right down, you can see the numbers changing there. We can go right to warp factor 9. Can't do it, Captain. We can do it. Look at that. It's going. Holy moly. And we just rolled over. So that is doing the job. I'm happy. We've got a reset button here so we can reset the count. A sample rate dial here. The ranges and whatnot for the counting, and a few other bits and pieces. I'm still figuring it out, all the nuances of this device, but I've got the basic functions down. Also, there's a switch down here for a test. If I flick that over, I should actually turn it to the frequency side. If I flick that, there we go, showing us the 10 kilohertz internal reference. So this uses a 10 kilohertz reference, and whatever you're putting in, it compares it and then use that to figure out the frequency and displays it on the screen of what you're inputting. Often newer equipment uses a 10 megahertz input frequency, and you can often find a jack on the back so that you can plug in a high accuracy, like a GPS disciplined or a rubidium standard, if you need that amount of accuracy. But yeah, this is a 10 kilohertz. It's a nice round number, so I'm going to say that's probably what it should be reading. And we are pretty much done. I still have to calibrate the dials inside. I still have to find the manual, but for now it's doing what it should be doing. It's looking pretty good. So I'm going to give that a thumbs up. Nixies are glowing, counts are counting, and I'm a happy camper. Alright guys, that's it for this video. Don't forget to hit that subscribe button, stick around, and we'll have some more videos for you soon. We'll see you then.